We're taking a look at a problem that analyzes codeine, which is C18H21NO3, and it wants us to calculate Kb from a pH. Now, codeine, which has that formula, is a nitrogenous base. And the way that I'm looking at him and thinking nitrogenous base is I know it's not an acid because it doesn't start with H. And then I see nitrogen, hanging out in the middle there. That's a hydrogen, my bad. Doesn't matter. But we have nitrogen hanging out in the middle there, making it a nitrogenous base. So the only way to analyze a weak base is going to be to add it to water in a rice table. All right, so get my friends set up here. So Bronsted-Lowry is going to state that my base here wants to gain a proton, so let's send one H over to him from the water. All right, so now he's got that extra H+. It came from water, so we need to remove an H+ from water, which is going to make hydroxide. Liquid water is ignored in a rice table. Going back to the problem, it gives us a starting molarity of 1.7 E-3, which will be my initial. So 1.7 E-3. All right, whoops. Is that guy there. We don't have any of these guys initially. So we can show our change, which is going to shift towards the zeros. So this is going to go down while this goes up. I plus C equals E. And now there's always another piece of information sprinkled in, and it lets us know that we're dealing with a pH of 9.59. Now, the actual question here is, what is Kb? So we're trying to find Kb. So we have a mismatch here, so you always got to check for that because my given item is in pH, but the X that's going to be our key to solving everything is connected to hydroxide, which is connected to POH. So I very simply need to find a POH to use here. All right, so I know that these two numbers together must equal 14. Therefore, my POH must be 4.41. Now that I have a POH, I can go to an OH concentration very easily by using our trick that says 10 to the negative POH is going to equal OH concentration. And when I do that, it's going to give me an OH concentration of 3.9 E-5. No, I was just saying hi. All right, and it was this that gave me that. All right, so now I know X, right? This right here is X because X is the OH concentration. So we can now set up all of our expression, which is going to state that Kb is going to equal the products C18, H21, NO3, H+, and OH minus. Those are all the products. And we put those over the non-liquid reactants. All right. So let's substitute this in now. All right, my values for the two items up here are the X's, which we have that value. It's 3.9 E negative 5, and I'm just going to square it, all right, because it's x times x, which is this times this, which that's a shorter way to write the expression, all right, over this guy here, all right, which is going to be 1.7 e negative 3. And look, it's minus x, and we know that x is this value, so minus 3.9 e negative 5. All right, so let's check this out. I'm going to go 3 point, got a glare there. All right, 3.9 e negative 5 squared. All right, and divided by 1.7 e negative 3 minus 3.9 e negative 5. And it gives me an answer of 9.2 e negative 7.